Hey guys, it's Andre here, and today we have a video requested to me by you guys. Some of you guys asked if I could do a little tutorial on how to create a Makefile. So yeah, let's get right into it. I did get a new keyboard, the Razer Black Widow V3 Pro, so we'll see if it's like super loud, and if it is, I might mute the video and then just do a voiceover. But what I want to show you guys today is how to create a Makefile, and in order to do so we're going to be using the Linux subsystem that comes with Microsoft. So you can do this in Windows. You can install the Linux subsystem, or you could also follow this tutorial if you're using Linux by just skipping ahead to the part where I actually start working on the Linux subsystem. Now I'll do a quick intro on how to enable the Linux subsystem on Windows. I'm not going to go in depth at all. I'll just do a quick overview just in case you guys need to set it up. So this is the official Microsoft document for like the US on how to install the WSL, and what we want to actually do is install WSL2. In there basically there's going to be a bunch of commands that you need to run on the PowerShell as admin. I'll show you the link here. Now you run this command to enable WSL like I said, then you want to make sure you have a build that is the correct version, then you run the next command to set WSL2. Doesn't say here, but you actually need to restart your computer, and then you can download the Linux kernel package that will allow you to actually use WSL2. Then you want to set it as your default version, and once you're done, then you can go to like the Microsoft Store and you can download like Ubuntu or whichever distro you want, OpenSUSE, Kali, Debian. I went for Ubuntu 20.4 LTS, and then yeah, once you download your distro, you open your power prompt as admin. You can see which, for instance, you can run this command that I have, and I'll put the link in the description, and it shows like I'm running Ubuntu on version 2 of WSL. This is what you want. This will be your distro, whichever one you choose, but you do want to make sure that you have the 2 here. And now that we got that out of the way, let's get into the actual subsystem. Okay, so I tried to make it a little bigger so that you guys can see better. Basically, once you launch Ubuntu or any Linux distro, you want to update and upgrade your OS. So on Ubuntu, it would look something like this, because it is the very like bare bones version that you installed, right? So this is how you would update and upgrade. I've already done this, so nothing is going to be installed for me. And then you want to install the equivalent of build essentials on your distro flavor. So if you do it on Ubuntu like me, then you can just install build essentials. After that, I would install an IDE. Of course, we're gonna go with emacs because it's a superior IDE. I'm not trying to start a war, but if you are a normie, you can go ahead and install Vim or any other IDE you want, but emacs is of course the choice. And then lastly, you want to make sure like that GCC is installed, right? So we can check the version, and for instance my GCC is not installed. We can install GCC. Yeah, it's going to require additional stuff. Of course, if we don't have GCC, we cannot compile C code, right? And this is a tutorial on how to make a C Makefile. So now we check the version, and we can see Ubuntu 20.04, and everything is good to go. And my dogs are barking in the background. I think I got a package. I'll be right back. Alright guys, so let's get into it. So usually in our code we're gonna have maybe some include files like in the C project, and then some source files, and we want to build that, right? So our structure, and I went ahead and already made this, but our structure is going to look like this. We're gonna have like a include directory. The name might be like include inc. You can choose maybe like object, where we can put our build object files, and then our source where our C files or C++ files are gonna lie. So first we're gonna do a basic Makefile, then I'll make some improvements, and then I'll show you what I would actually use. So in order to actually create and build our project, we let's make some files. So we'll make a hello world.c. We'll have include hello world.h, our header file, and then we'll have our main function, and then we'll call some function like hello world function, and then we return 0. And then this is going to be a very simple hello world like C file. Let me make this, there we go. And then we'll make a hello world.h file, where we're just gonna have maybe basic headers like stdio.h, and then, or actually no, these are header files, sorry. There's gonna be some sample header file, hello world style. And then in here we're simply going to define our function. Hello world function is going to be void, takes no arguments, void, and then that's it. And we can have our hello world function.c, and in here we'll define stdio.h, and we will include the header file. We can say hello world.h, and then maybe we can have our function. It's going to be void, and maybe in this function we'll do like a printf Andre's Makefile tutorial. And then we return, and boom, we're done. We have our 3 files here, and usually if we were to compile them, right? If we were to compile the C files, we would do something like gtc, our output, let's say it's hello world, and then we have our hello world.c file, and we can have our hello world function.c, and we can say like include like the local files, and if you can see, it actually created the object file hello world. It's an executable, right? You can see it's highlighted in green, and if we run it, boom, Andre's Makefile tutorial. That's actually, I don't like the fact that it prints it, so we'll add a new line character. So emacs hello function, boom. So if we do compile again, boom, prints it in the new line, and we're good to go. So I'll just remove this. So now, instead of like having to type that out manually, we can make a Makefile. So emacs Makefile. You didn't need to name your Makefile like Makefile or Makefile like I did. I like the naming convention the best, but it's just a preference, you know. And then in our Makefile, we can have our target. Very simple Makefile, be hello world, and it's going to take in hello world.c, hello world function.c. Here it's very important, if you make a new line to run a command, to have this tab space, or GCC is going to complain. Then GCC-O for our output, hello world, and then we'll have hello world.c, hello world function.c, and then to search in the local file. Alright, so then if we do make hello world as our target, boom, right, it makes the hello world, we run it, and it worked. But this is a very simple Makefile, right? So we want to improve this a bit, because like, yeah, this, like, how is this different than simply running the script, right? So let's actually add some like variables and stuff to make it a little nicer, and then I'll show you what I would probably use for like a small project or something. So we can say like cc, this is kind of convention to set our compiler to cc, and then we have as convention like c flags, any flags that we might pass in, like for instance like wall and -g, and then maybe some L flags for like linking, and then we can have like our dependency file, and I'll actually and it's actually, well, I'm pretty, yeah, well, okay. And our file here would be hello world.h. And so now we can actually start do some like replacement, and you know, try to make it a little better. Like for instance, we can have it in order to, if the issue with our current Makefile right now is that if something changes on the input file, it won't, on the header file, it won't take it into effect, and we want it to compile. So we can change it to compile, and then we'll have some Makefile like syntax to do output. Let's see here, so that it will look at our dependency file hello world, see if there's any changes there. That very important. This is just a way to use a variable, right? So it's going to replace this into here, gcc as well. Then we have output, and what I'm about to show you, it's maybe a little advanced. It's kind of convention. Basically, the at and the less than symbol are kind of like special macros to kind of implicitly take the name from like the C and the O object files into and then like we can make this a little better, right? Like gcc output hello world, and then we can actually, because we're already linking, we can change this to output file just like this, change this to this, and then ls, and then we can make boom. But you see, I don't like this approach because oh, and we actually save the buffer file. It actually just like spits all the files into here, and then it did make the executable, but it's like, you know, it kind of like spit the files into like out here. So let's try to clean it up. So we'll remove all object files. There There we go, and then we'll remove this like weird Makefile buffer file that I accidentally made. Remove hello world. So this is what we're gonna do. We're going to move our header file into the include directory. We're gonna move our C files into source, and then we're gonna keep our Makefile at the root level. So then, now this is where it's gonna get intense, but I will show you how I would do my Makefile, and then I'll try to explain a little bit as we go along. So we're gonna, as before, we're gonna try to use some variables to kind of clean this up, make it nice and presentable, following this like basic C structure that we would have. So our compiler in this case is gonna be GCC. Our C flags are like wall and G, they're like basic standard for adding like debugging, basic flags. Our linker flags, if we wanted to add maybe like a library or something, you would actually use this for like a library for like linking, maybe like lib or some directory there. But for now we're not actually going to use it, so I'm going to comment it out. And libs, if we want to link to any library, for instance, one of the most common libraries that is used is the math library. And sorry, you might hear my sister in the background, sorry about that. Then we'll have our include directory, and that is going to be where we have our header file. So in this case it is in the include path, and then we'll have this variable, I like to have it like includes, and that is just going to be the flag to include our include directory. Then we can have our output directory where we want the output .o files to go, and it's going to go into the object, and our source directory where our C files are, and that is in source. So I think up to here it's pretty self-explanatory. Then this is, we're going to start doing some what I call Makefile magic. So we need to obtain some of our values, and we're going to be using some like GNU Makefile commands. So we're going to have here sources, and that is going to be essentially a list of all our C files. We don't want to type them out like with it here, that's like noob level. We're not noobs, right? So we're gonna just use some wildcard, and we're going to look in our source directory, which is going to include the hello world.c and hello world function.c. And then we're just gonna look in our source directory and take all the C files, right? Nice and easy. And then our objects, our output files and this is are just gonna be those same files, right? But instead of a .c, they have a .o. So we're just going to change sources, and we are just going to change the .c to a .o. Using some string replacement here, and then our dependencies in this case are header file, right? And wildcard in our include directory, and it's all .h because it could be more than one. It is just one in this case, but we want to keep it nice and generic. Then I like to, in order so we don't have to type out like make, and then our target, I like to specify the target. In this case, the target is going to be hello world. And then like we also want to have like a cleaning method, right? Phony depend and I'll explain this in a sec. Basically, we're just going to be cleaning. That's what this line does. We add phony so that if we have any file named clean or something, our Makefile is not going to interfere with it. And then our default like all make command is going to be our target. And let's say if this is run, we can run like a simple echo, maybe like simple make command, or maybe simple hello world. Hello world make file created by Andre. And then when we actually run our target, in this case it will be named hello world. So we want to be looking at the objects, and then this is kind of what we did before here, like basically the steps, except we'll make it a little better. So we're going to use our GCC compiler, our C flags, our includes, so it's going to include our directory here to look for the header. Our output names is going to be our target, right? Our output, that's what we want it to be, so that the executable is named hello world. And then we have to pass in the objects for the .o. Any linker flags, in this case it's going to be empty because I don't have any libraries that we want to link. And then any additional libraries we want to include, like the math library, we pass it in. And then let's see basically this is for building the object files, that's what that means. So we will use GCC and our C flags. I include directories as well. And then this is a bit of parsing so that we can take the name from the input. And then this is going to create our object file. So now we want to specify how to clean. So basically when we clean this, we want to remove our output directory .o files, and then we also want to remove our target. And one thing I like to do is, because this will actually build the object files inside the source directory, I like to have just a nice move command. You can do this through Makefile, but it's a little advanced. I think it'll be better for now to just do it through move command. We can move all the object files to our output directory and from the source directory. And then maybe we can say here, echo cleaning Andre's and the Makefile created by Andre. And then depend, that is this target's used for like linking sources. May reset the line. Make depend include. There we go. And once you create a make depend, you kind of need to keep this line. Don't erase. Don't erase that line because it will get messed up. It's needed just by convention. So basically, these are the paths where I want to store my objects, where my C file, like source files will be, where my header files will be, and then I just parse them out. Obtain all the C files, all the header files, got the names for the objects. This is the name of the executable, hello world. We want to use a phony clean so that we don't phony, you want that keyword so that if there's a file named clean or something, you don't mess it up. If we just type in make, it's going to execute this. If we type in make hello world, it's going to execute this target, which is what will be executed by default. This is what we had before, just all variables, so it's nice and simple, and it will compile and make everything, and then These are the rules how to make the object files from the C files. We don't have any special flags. We add like debugging info, like remove warnings. We're adding the math library here. Where is it? Here. This is how you would add any additional libraries you want to link. This is how to clean. And now let's test it out. Let's remove this temporary file. So then if we do like make clean, for instance, cleaning the make file, but there's nothing to be deleted, right? So let's do a make, and then if we see it actually create a hello world here, and if we do a ls include, we can see our header files inside include. If we do an ls in object, we can see our 2 object files were created there, and ls into source, we can see our source files are there. And then we can execute our hello world executable, boom, and it works. I will add the code for this file. It will be in my GitHub. I'm gonna push it. I'm going to add the code in the description. Very nice and simple. If you have this structure, it will just work. The only thing you will have to edit if you do it is like the name of the executable and like the actual contents of the C files. But yeah, I hope this was a pretty easy tutorial. I hope you were able to understand everything. If you did not, or you wanted to explain anything in more detail, just shoot me a message, leave a comment in the description. And yeah, this is how you make a simple Makefile.